Okay, right. Well, we'll start now. And there we go. Teaching 5 years, IT Servo, Portugal. Excellent, Joe. That sounds fun. Third year teaching. I'm just in charge of computing. Okay, that's great. What we'll do now is we'll start the session properly, and that background will hopefully give me enough information to tailor it for you. As I say, feel free to chip in as you go along, or ask any questions as we go. So let's start properly, and we'll move into the outcomes of what we're hoping to achieve from today. A large part of what we can try and look at is the move from ICT to computing. So by that, if you're new to computing as subject leaders, we can look at what your head might not know about computing and what they might be assuming from ICT is happening, because there is quite a lot of change, and generally what happens is they'll pick somebody, you'll get dumped with it and left to get on with it. So you're really the expert there to know what's going on. So hopefully we can address that if you feel under-equipped in that role today, and we can look at how you can start to properly lead the subject, knowing exactly what's going on, knowing what Ofsted will come in and look for. Not that everything's to do with Ofsted. See, it took me 3 minutes before we started talking about them. And then we're going to move on to looking at how you can really tailor the computing role to make sure that it matches what you want to do with it as your lead role in school. And then we can try and work out a way that you can create a rich yet cost-effective computing curriculum, by which I mean picking particular resources that are free or cost-effective, and then as you are managing to get cash from the areas that be, you can then start to make things more and more exciting. And I'll give you the example that we've used in our school that's worked incredibly well so far in the move away from ICT to computing. We'll then briefly look at planning for staff training needs. So if you are fairly new to a subject leader role in general, that will help you there. And like I say, if there's parts of it that you want to just skip over, we can. But if you find you need more detail or you want to ask questions as we go along, then do so. And at the end, as I said, the main area which we'll see very, very soon is an increase in the focus on computer science, which is where you'll find all of the algorithms, programming, and coding. It used to be called control, and it was still there in that guise, but it's been beefed up at the behest of the powers that be, and so that's what we're going to cover. So moving first of all into ICT to computing. Or not, I don't know how that's happened. I'll just skip through, working backwards still. It's a day for technical issues. There we go. We can get out of that one, no problem. Right. So, in the move away from ICT to computing, the list of characteristics on the left-hand side were really what you'd see in ICT. You'd have your users, you'd have your children that would consume different apps, or whether it's websites or software. They would communicate possibly with each other through the computer. They would try and become digitally literate. They would also try and stay safe online, and they build up a bank of skills, whether it be using something traditional like PowerPoint, or whether it be something at the time seemingly more cutting edge, like a new piece of software that had just come onto the market. And now computing has changed that. So really, you can see yourselves that instead of becoming users and consumers, the focus is far more on the children becoming more equipped to create. So whether that's in the role of making programs, or whether it's in the role of making applications for other children to use. It's also a subtle shift from communicators to collaborators. So you're now really focusing more on getting the children to work together to solve problems, to build solutions to different things, whether it's an actual more mathematical based problem, or whether it is a problem like we need to create a presentation for this group of people in a more of a traditional role. Possibly the biggest change is the next two, becoming digitally critical and also becoming responsible. So the onus, whilst it's still important for schools to have filters in place for children's e-safety, the onus is now shifting. So we as staff and subject leaders need to be really clear about how we can keep children safe. We need to have tight policies and all the usual things, but it's now far more onus on the children to take more responsibility for that. So there's a degree of what we need to teach the children lying in there within e-safety really, and within digital literacy, which we'll look at later on. So it's all about making sure that the children are far more proactive throughout the curriculum really, and hopefully what we'll look at now will help you create that. Absolutely critical as a centerpiece to everything is this one sentence from the DFE from 2013, which is all about computational thinking, which you will be memorizing by the end of this session. I'll read it to you as well. There you go. A high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. So basically, this is the statement which everything else is going to be coming from. So that is a large chunk of the computing curriculum. How large it is we'll look at in a minute, but this is the shift from ICT to computing. This kind of embodies that shift. So really we're looking now at children who are able to use computational thinking, whatever that is, which we'll look at in a minute, and creativity as well, to understand and change the world, building programs, being able to interact and make unique solutions to problems. Can you just type in the chat if you have or have not ever heard of computational thinking, and then I'll know how much depth to go into it, bearing in mind there are other people that will purchase the recording. Mary, see, you were worried, but you're ahead already. Okay, fabulous. We'll move into it then. Let us know if you need it any faster or slower. So there are 5 or 6 areas of computational thinking. It's generally regarded as the 5 that you can see on screen. Also, some people would add in evaluation into that as well. I've left it off because it's, to be honest, it's nothing new. If you think of evaluation just as you would in a subject such as design technology, where you'll be throughout the unit and also at the end of a unit evaluating what works, what doesn't work. It's the same kind of thing that you'd be looking at for computational thinking, and working out what strategies you used that worked well or didn't work. So the other 5 areas are listed in front of you, and this is where we're really starting to look at the change to ICT, which has become computing. Logical reasoning, where you would usually find it in maths, most prominently in problem solving, which is why I've got a little challenge for you to do to start off with. We've got Maisie the Maze here. This is what logical reasoning is. It's thinking of a way through a problem, not always as literal as a maze, and working out a logical way to approach something, and those skills can help you a lot when you're looking at the computing curriculum, particularly computer science. So if you could have a go at this problem, that would be fantastic, and type in your answer into the chat. We've got somebody with sound not working. If we could just get a little bit of help with that, subject support. Just chat to them myself. Right. Maisie the Maze explored the maze. She always went forwards, so you cannot go backwards. You can't double back on yourself. It has to move towards the way out. How many different ways are there for Maisie to go from the start to the finish? This is actually a year 2 problem from a Finding All the Different Possibilities pack that was sent out a few years ago in maths. If you could have a go at trying to work that out and think about, whilst you're doing it, logical reasoning. So we are looking for a logical solution to it, a logical way around it. Have a little go, and just give you about 60 seconds for that, and type it into the chat when you've got your answer. Joe thinks 6. Mary thinks, the answers I usually get are 6 or 8. You're both spot on, and basically there's several different logical ways to work this out, but all are as valid as each other. You could start, what I did was I would start at the start, go straight along to the left hand side and straight up to the right hand side, straight up to the way out. You could then go from the start all the way halfway towards the middle and zigzag upwards, and then from the start go towards, oh, I've got a cursor I can show, that's easier. Right, so you can either go that way, or you can go zigzagging, or you can go this way. I know you guys know this, but if there are people who are purchasing the video, they'll need to know as well. So we've got the three there. We can then flip it and flip all three onto the other side as well. Other people might have started either this side or the other side like that, and then thought, well, if that's one, I've got two here because it is symmetrical, and then worked it out doing the exact opposite each way. So you've got at least 3 different ways that you can work that out without any being particularly right or wrong. So the point is, you can, when you're looking at any kind of coding, programming, or responses to computer science, there is no one way usually to work something out, and often there are many valid ways, and getting the children to be able to use their logic and understand it from a kind of a mathematical perspective can really help them